Assalamualaikum and good day everyone. So today we are going to present a final assignment for subject Signal and System, code BET 2423. First of all, let me introduce my group members. The first one is Muhammad Hazim bin Hashaini, then Ahmad Irfan bin Harman. After that we have Muhammad Shafiq bin Yaakob, and finally Muhammad Hazim bin Mazlan. So this is a group assignment. It consists of introduction to the project, description and elaboration of theoretical aspects, the methodology, and finally the result and discussion. Convolution. What is convolution? Convolution is a mathematical operation on two functions that produce a third function that express how the shape of one is modified by the others. The terms of convolution refer to the both result function and to the process of computing. For this assignment, we use convolution function. Then sound. What is sound? In physics, sound is a vibration that propagates as an acoustic wave to a transmission medium, such as a gas, liquid, or solid. Sound also defined as oscillation in pressure, stress, particle displacement, particle velocity, propagate in a medium with internal forces or the superposition of such propagate oscillation. Sound also can be viewed as a wave motion in air or other elastic media. In this case, we convolute or manipulated the sound using MATLAB software. The types of sound. For this project, we need to use three types of sound. So, for human sound, we use cawing sound. Then, for animal sound, we use rooster sound. And finally, for thing sound, we use guitar sound.
Okay, so for now I want to present the time domain and the frequency domain that we get from the audio file we choose. So we call the function audio rate to read the audio file. So we set the variable x equals to x, which is this is the first column of matrix y, matrix x. So we create the new variable which is dt1 equals to 1 over fs to. So this is to get the discrete time values. So t1 to set the range from the 0, the interval is dt1 and until the length x times dt1 minus dt1. So this is the limit is 2.5, so the interval is 0.5. Okay, so for the subplot we set 311 and we just make the x label and y label, and for the pattern. Okay, so for the y, for the guitar, the mp3, we same here for we do the code. So for y and z we do the same from the previous code. So we get this after we run, we get this time domain for the rooster sound, time domain for the guitar sound, and time domain for the curving sound. Okay, so for the frequency domain, we call the FFT function, which is FFT is discrete Fourier transform. FFT is the discrete Fourier transform of vector x. So we call the function and we set to the new variable which is c, and n for the length, which is the number of samples, f for the frequency of range, we set the range, and a is the power of the discrete Fourier transform. So we just set the label which is frequency for the x axis. So we subplot 311 and we just plot the f and a we get from here for the variable. Okay, so for this is for the rooster sound, and for this guitar sound we do the same here for the code, and for the curving sound we also do same here for the code. So this is the result for the frequency. This is the frequency domain for the rooster, and this is the frequency domain for the guitar and frequency domain for the cuff. Okay, so firstly we have three different sounds, which is cuff, rooster and the guitar. So firstly we hear the sound of cuff. Okay, so this is the sound of rooster, and then the sound of guitar. Now we will explain about the convolution for the recorded signals that we have used for our given assignment project. So first we define the figure 3 for the figure 3, and then we set for the input signal as we have chosen here is the rooster, and we subplot and plot. After that we label accordingly. For the second we use for the impulse response is the guitar sound, and then for the third subplot, which is we use for the convolution of the sound X and Y, for the given convolution of the rooster sound and the guitar sound. So this is the expression to use for the convolution, and we limit it to 1 EPI and 2 EPI accordingly. So now we run first for figure 3. So this is the figure 3 of our given figures. So first we have the input signal and the impulse response of guitar, and the third is the convolution of the sound of the given sound. Okay, first I will run for the input signal. This is the rooster sound. This is the guitar sound, and I will run for the convolution. Headphone warning, okay. Okay, that is the convolution sound of sound X and Y. Moving on to the figure 4. For figure 4, we use X and Z. For the input signal, we use rooster, and the impulse response is the cuffing sound. And the same could be said for the convolution of sound X and Z. Now we run the convolution of the sound for figure 4. So that's it for convolution of sounds of two different types of sounds between XY and XZ. Thank you.
Discussion. Based on this assignment that we have conducted, using 3 selected recorded signals, we are to find and do the convolution and generate the impulse response. We have conducted a procedure to compute the time domain of selected sounds. From the codes, we have generated the time domain, frequency domain, impulse response, and the convolution of the sounds. The sound that was input through the MATLAB could be playback after having done the convolution process. We could observe that there were major differences in between the time domain between the sounds, thus contributing to its impulse response signal range. The convolution will produce a third function which could be expressed in the sound term. Conclusion. To conclude, in this assignment project, we are able to understand the basic concept of convolution. Using the recorded sounds that we have selected, we are able to conduct the procedures given to generate the convolution, impulse signal, and other suitable signals. The output that were generated varies as the modulation basically projected a third function from 2 or more sounds or functions to be processed. Lastly, we are able to write and fathom the codes in order to generate these signals according to the procedure of the assignment project.